Okay, YouTube, this is our second video in setting up and solving systems of linear equations with application problems, in which we're just going to kind of continue our exploration of the steps we take in order to solve such problems. So let's go ahead and take a look at these two examples here. Number three, reading through this, it says one Reese's peanut butter cup and one Twix bar contain 510 calories here. Now, as I read through this, I'm actually inclined to underline this. It sounds like an important piece of information. As we read on, it says 2 Reese's peanut butter cups and 3 Twix bars contain 1,440 calories. So what we want to do is determine the number of calories in each type of candy bar. So as we do traditionally with any application problem, the first thing we're going to do is start by defining our variables. And because I know that there were 2 different types of candy bar, then I'm just going to go ahead and define 2 variables here. And in each particular instance, this is very important that we allow these to be a number of something. And so I know you're inclined to say that it's a number of, say, Reese's or Twix bars, or, those are our 2 variables here, I guess, that we're exploring. But the moment you say that X is a Reese's peanut butter cup, I guess what I'm saying is I can't eat a Reese's peanut. I can eat a Reese's peanut butter cup. I can't eat an X. And so we have to say that X and Y do represent numerical values. So it's kind of a standard thing. We'll write number of on each of these. And what we're trying to find is the number of, and check this out, calories in each candy bar. So we say number of calories, and we'll just say in a Reese's here. And then for our second part of this, this would be the number of calories, okay, in a Twix. So now that we have these defined, what we want to do is essentially set up the relationships that we see up here in the words as a problem or an equation. And so we need 2 equations here since we have 2 variables. But what we were told is 1 Reese's peanut butter cup and 1 Twix bar contain 510 calories. Now, an important theme we're going to see here with at least 3x3 systems is that we need to match up units. And so what I mean by units is, I guess if we said 1 Reese's peanut butter cup and 1 Twix bar contain 510 calories, then the way we're going to look at it is this way. We have 1x plus 1y comes out to be 510. And just to kind of go through my explanation of what I mean by units here, since 510 is being measured in calories, then the left side of this equation also has to be representing calories. But what I know is this, the 1 and the 1 out in front represent the number of each type of thing we had. So in other words, we're saying 1 Reese's peanut butter cup times the number of calories per cup plus 1 Twix bar times the number of calories per Twix bar should give us the total number of calories in this combined thing. And so setting up our second equation, reading through this, I suppose we had 2 Reese's peanut butter cups and 3 Twix bars. So we say 2 times the number of calories in those 2, or in one of those, which would give us the total number of calories in 2 of them, plus 3 times the number of calories in 1, which is the total number of calories in 3. This comes out to be 1440. So now that we've got our system set up, essentially what we want to do is go ahead and solve it. And so you're going to see that, yeah, we're dealing with a problem here that's got a little bit more inflated numbers. In terms of a method, I think that it would be wisest to use an addition method or a linear combination or addition method here, or elimination, sorry, and we'll eliminate our x's. So distributing the 2 throughout this, looks like we get negative 2x minus 2y. And if we take 510 times a negative 2, I guess I could do this one in my head. It's 1,020 right here, negative. And so we would get that in our second equation. Of course, we didn't do anything to our second equation in this particular instance. And so as we rewrite this and cancel out our 2x's, what we see is that we get a single y left over. And let me go ahead and grab my calculator here. I suppose this would be 1440 minus 1020. That would give us the same thing here. And so adding these together, we get 420. So 420 is our y variable here. And as we plug this back into the original equation, I suppose we get x plus y equals 510 calories here. Then we would say, well, then really x plus 420 equals 510. And so as we subtract 420 from both sides here, minus 420, minus 420, then when we get this is this difference on the right here that comes out to be 90. And so what we discover here is that our solution, and remember that we do want to write our solutions as ordered pairs, is 90 comma 420. So with respect to application problems, this is probably the most important part of it, but what we wanted to do is determine here essentially what these basically come out to mean. And so in terms of this problem here, I suppose we could look at this is, we said that their calories added up here to 510 if we had 1 of each. And if we were to double our 90 here and triple our 420 and add those together, we get 1,440. So what we've just discovered here is that there are 90 calories per x. So in a Reese's, okay, a Reese's cup. And there are 420 calories, okay, in a Twix here in this particular instance. So what we're going to look at is just another example here below this one, where we're carrying out the same steps but with a little bit different situation and seeing what we can piece together here. So what we're told is that a restaurant is to contain 3-seat tables and 4-seat tables. So already as you read through this, think about how many variables do you think I'm going to see here. It says fire codes limit the restaurant's maximum occupancy to 90 customers. So we have a 90 customer total. If the owners have hired enough servers to handle 25 tables, how many of each kind of table should they purchase? So now after reading through this, let's go ahead and take a look at the fact that what we're asking ourselves to find here is how many of each kind of table they should purchase. So we're going to say, defining our variables, we notice that there were only 2 types of tables here. We would say that there were 3-seat tables, so I'm going to say 3-seat tables, okay? And one thing that I've already forgotten is the number of. We say the number of here 4-seat tables for this guy. So as we've defined these here, we want to figure these out. Let's go back up and look at these quantities that we were told. Now, when they said that the fire codes limit the restaurant's maximum occupancy to 90 customers, what we're going to need to do is then come up with what we're going to say is a customer's equation. And so when we talk about customers, I suppose what we mean is we want to match up units. So that is to say that that 90 customers, chances are that that's the total number we're going to get over here, but how would we describe these in terms of X and Y on the left? And so remember that when we're talking about customers, they brought up customers here by saying that there were 3 customers per table and 4 customers per table here. And since X and Y just represent the number of tables, then what we're really going to say is this: 3 customers times the number of 3 customer tables plus 4 customers times however many tables that we have that are 4 customer tables. If we were to add all of that up there, then we should have a maximum occupancy of 90 customers. So our customers equation is 90 here. Now what I see here is that this other one, this 25 here, this is tables. And so I could look at this second equation as all having to be in terms of tables here. And so when we talk about tables, well, they did talk about 3-seaters and 4-seaters here that go with our 90, but there was no talk about tables over here to represent our 25 to add up to our 25. But the thing I want to mention here is this, that sometimes your variables are already in the units that we need this to add up to. And so that is to say that if we said there are a maximum of 25 tables, then we could say that the expression that represents this is the number of 3-seat tables plus the number of 4-seat tables comes out to be a maximum of 25. And so you can see that, yeah, setting these up is probably the most complicated part of this. But once you get to here, let's go ahead and solve this and see what we can come up with. So I suppose that if we were to do this, I would choose to do elimination method or addition method, and I would eliminate my x's. So our first equation, 3x plus 4y, is still equal to 90, but here we get negative 3x minus 3y, and this would be equal to negative 75. So summing these, x's kick, we get y to come out to be 15 here. So I'll put a box around this, and I'm going to make sure that I'll even keep this in red, that we write the solution over here. And so we would find out that of our ordered pair, we have 15 total 4-seaters. And so as we plug this back into either of the original equations, I'm inclined to do this second equation here where we had the sum of these two being 25. If y is equal to 15 truly, then what we determine here really is that x comes out to be 10. So this being said, we'll go ahead and put in our 10 over here. The last thing we want to do is just go ahead and interpret our results. But what we would say is that essentially we have 10 what? Well, 10 x's, and x was the number of 3-seat tables. So there are 10 3-seat tables. And then we would say that there must be 15 4-seat tables. 4-seat tables. Cheers.